Hi, Professor Bob Young here, and in this video we're going to talk about the VERTEX formula, and we're going to do some application problems with quadratic functions, or our friends the parabolas, entitled minimum maximum problems, which you business majors, you will see those. All right, so let's refer you back to the handout for this section that's in your supplemental handouts that we've already talked about. Now, in the first video, we were graphing parabolas and we were finding the vertexes and domains and ranges and all that good stuff using this standard form equation there, and we were changing this quadratic form into standard form by completing the square. Now, not everybody likes completing the square, and there is another method I want to show you that will help you as far as getting the vertex goes, and for minimum maximum problems it works great. And here it is. To get the x part of the vertex, if it's in this quadratic form, let's think about those a, b, and c numbers again when we were playing with the quadratic formula way back. And to get the x part of the vertex, we just have to use this little remembrance of minus b over 2a. Now, once we get that number, you just plug that back in for x to get the y part of the vertex. And everything else pretty much works the same. So if you can get the vertex of a parabola, life is good. Now, one thing I haven't mentioned here, and that is something to do with the discriminant. Now, the rest of this stuff we talked about in previous sections here, but number 5 here, if you get the discriminant of the quadratic function in this form, notice that you can figure out what the x-intercepts are. So when the discriminant is greater than 0, you're going to get 2 x-intercepts, and if you solve for x using the quadratic formula, there's our friend I told you about, then you can find the x-intercepts that way, letting, if you know that that discriminant is greater than 0. Now, if it's equal to 0, you're only going to have 1 x-intercept, and that's going to be the minus b over 2a number, whatever that is. And if it's less than 0, it's not even going to cross x. All right, now what do we mean by that, Young? Well, the first part of number 5, if it crosses x twice, it would look something like this. See, those would be the x-intercept once you use the quadratic formula to find those numbers. The second part, if it crosses it once, it could go anyway, so we'll just do it. And again, my writing tablet, forgive me, it should only be hitting x once there. And then some parabolas on the third part, they may never cross x. They may be up here somewhere. So that's what I mean by that, in case they give you any discriminant problems. All right, now let's get back to our friend, the ax squared plus bx plus c quadratic form here. Now we're going to go ahead and use the old minus b over 2a here. So in here, to get the vertex, we're just going to say, hey, a is 2. And b is 4. Now, of course, if you completed the square on that one, think about it. You would have to factor a 2 out, move the 5, take half, square it, and then watch out for all that stuff. I mean, it would be kind of bearish if you think about it. Here, we're just plugging in 4 for b and then 2 for a, and we get the x part of the vertex, whoop, -1. And then we're going to take that -1 and put it back in for x wherever we see an x. And look how nice this is, ladies and gentlemen. Y comes out 3, so we get the vertex of -1, 3. So even in this quadratic form here, let's go ahead and graph that. So -1, 3 is our v number. And you know Young, he wants to make a table of values here, not a big one, so we can start doing the old buy one, get one free here in this form. So we've got -1, 3 is the vertex. I'm going to put v here. All right. Now, does the parabola smile or frown? Think about that. And again, the a number is in front of x squared. What is it? It's positive, so I'm thinking it's going to smile. It's going to go this direction. All right. Now that axis here, notice, is going to go through x if we extended that dotted line downward at -1. So once you get the vertex, you've got the axis as well. So that's nice. All right, now just another point or two, and we'll finish this one. If I put 0 in for x here, that's a nice easy point to the right of that axis of symmetry. F of 0 would be 2 times 0 squared plus 4 times 0 plus 5, and I would get y is 5. So if our theory is right on the A number, it should be somewhere up here. Oh, look at that. It's starting to smile already. And here's the buy one, get one. If you've got that point, it's one away from the axis, you've got that point. And then you could get some more points, but the general thing here is this parabola would go this way. Now, I bet y'all if you did the discriminant on this problem, just remember the discriminant is b squared minus 4ac. If you wanted to play with that one with this problem, I bet you it would be a number less than 0. See, because this does not cross the x-axis. That's what I was saying earlier about that. If it equaled 0, it would cross x only once, and if it was greater than 0, it would go through x twice. So that's what I was talking about on that. What's the domain? You know, we've done these before, many of them. So the domain of any functional parabola is going to be negative infinity to infinity and beyond, Buzz Lightyear. The range, and again, the vertex will help you get that if you haven't gotten that from previous lessons. And I'll go ahead up here with red. That vertex number of 3, it starts at 3 on y, and this is the y-axis over here, so be careful. And heads upward would be 3 to infinity. And it includes 3. So our friends, the quadratic functions. All right, now let's graph one more in this form here. So now this one would be another one. If you tried to complete the square, it might be kind of ugly. So this is what I mean in this form, that you can go ahead and you can get the x part of the vertex. So I'm going to write that here, x part of vertex, by just taking minus b over 2a. Now, what's the A and B numbers? Well, hopefully up there you're looking at it and you're saying, well, B is 24 and A is negative 3. So you get minus 24 divided by 2 times negative 3. Now, that would be a negative 6 in the bottom, so you would get a positive 4. Y'all see why that would be positive 4? You got to watch your signs here as well. And to get the Y part of the vertex, we're going to go ahead and plug this 4 that we found for the x part back into the function. So we're going to evaluate this function f of 4. In other words, when x is 4, what do we get for the y value? And we'll put in that and get negative 3 times 4 squared plus 24 times 4 minus 46. And I believe you'll find that that comes out to be the number 2. So we know that the vertex here, and we'll go ahead and write that up top here, is 4, 2. And that is the all-important point in graphing any parabola. Now ask yourself, does this parabola smile or frown? And this A number right here, again, will tell you this one's going to frown. It's got a negative value for A there. So we know that it's going to head this direction, and I'm going to go ahead and sneak in this axis of symmetry here, which will cut the parabola right down the middle, and we will call this axis x equals 4. So from the vertex, we can find the axis, and we can find the range as well. Now we know the domain for any functional parabola is negative infinity to infinity and beyond. And the range from this vertex we can get, we know the parabola is going to frown here, is going to be negative infinity to 2, which we will now show as we graph this creature. Now again, remember, if you want to graph a parabola, now that we know this symmetrical connotation here, we're going to go ahead and put some values to the left of that vertex point when x is 4. Let's go ahead and plug in 3 for x, and I'll make my table of values up here, and we don't need a whole lot now, remember. All right, so if we evaluate the function when x is 3, And that, again, is just substituting in wherever you see an x3 where we put the 4 there. And there are some tricks on your calculators. You can kind of change that 4 to 3 real quick on your calculator when you get good at it. And you will get -1 for y if you do that. And I'll plot that point. So it does look like the parabola is heading the correct direction here. It is frowny. And here we go, the old buy one, get one free BOGO. If the point 3, -1 is on the parabola due to the axis of symmetry, so is the point 5, -1. So we'll put BOGO there. And we'll get one more point just to ensure the parabola here. If you plug in 2 for x, wherever you see an x in this function, f of 2 will come out to be -10. So I'll save a little time on the video and just put that point in here. So I'll go up here up top to -10. Go way down here south of Dixie and plot that. It's still heading a good direction. Now notice this point is 2 units from the axis of symmetry, so I can go 2 on the other side, and you can bet your friends this if you want to, if you're a betting person. Hey, I bet you that 6 will also give you -10 if you plug it in there for x, and see if you have any takers. You could become rich. And then let's go ahead and put the parabola, the beautiful graphed, parabola here in pretty green. Now make sure you have a nice round tip on your parabola there. You don't want to make it look like an absolute value function or a v from previous sections and stuff, so make sure it's roundy there. And I would say that's a pretty accurate parabola here. So I think what we're going to do next is move on to Young. Where do you use this in real life? Minimum, maximum application problems. We'll do a few of these and finish out the video here. Let's say we got Miss Harris has a taco stand. Makes me want to take a run for the border. She has found that her daily costs are approximated by this function, c of x equals x squared minus 40x plus 610, where c of x is the cost in dollars to sell x units of tacos. So find the number of units of tacos she should sell to minimize her cost, and what's the minimum cost. Now looking at this function, hopefully you recognize that you've got a parabola here with a positive a number. So if you think about that, and this is how business people interpret this, that vertex is going to be your minimum there, because if that's positive, it's going to smile, and that vertex will be your smallest value there. Now, how do you want to get that vertex point to get the x part of the vertex? Then down this road, minus b over 2a. So you business majors, I mean, if you don't want to complete the square, this is really good for these type problems. So plugging in here, now watch your signs on this one. B is a negative 40 over 2 times a. The a number is 1 in front of the x squared, and that gives us a positive 20. All right? So she would have to sell 20 tacos. Now, what would the cost be here? What's the minimum cost? Well, if she sells 20 tacos, if we plug 20 in for x here, we're going to get 20 squared minus 40 times 20 plus 610, and the cost I get to be $210. So in this case, looking at this function, here is 20 tacos for $210 would be your answers. That vertex will tell you all. All right, let's try one more and we'll finish this video. Minimum, maximum problems. If an object is projected upward from ground level with an initial velocity of 32 feet per second, then its height in feet after t seconds is given by this function. S of t equals minus 16t squared plus 32t. It says find the number of seconds it will take to reach its maximum height, and what is its maximum height. So hopefully you're looking at this parabola and you're saying, well, that negative a number, it's going to frown, and that vertex would be its maximum. Now, does the military use math in their adventures? Yes, when they launch something, I think I just woke my dog up over there. You know, math is not always used for good things. Or you might think about baseball. he hit a home run, it's out of the park, or maybe one of your favorite quarterbacks, he's throwing deep a football. I mean, that's a parabolic thing. There's lots of parabolas in nature. DirecTV, your dish, where would we be without parabolas, ladies and gentlemen, or the Dish Network or anything? So there's a lot of real-life uses for parabolas. Now, if we want to find the maximum of this problem, again, we're going to do the minus b over 2a to find the x part of the vertex. So the b number is 32. The a number is negative 16. So I get 32 over 30. That's going to come out a positive 1, isn't it? All right. So it looks like after 1 second, man, this thing must be going here to get to its maximum height. It doesn't take it long. Things fly. Okay, so we're going to put in s of 1 here and figure out what that maximum height is. It's going to be negative 16 times 1 square plus 32 times 1 equals negative 16 plus 32 would be a maximum height of, it looks like, 16 feet. Maybe it's one of those little bottle rockets you see dads take their kids out or daughters and launch up there and have fun. You know, those things will take off pretty quick, and they will also go in a parabolic form. All right, so that is a different way to find the vertex of a parabola in quadratic form, ax squared plus bx plus c. Use the old minus b over 2a to get the x part, plug it back in to get the y part, and then you won't have to complete the square. All right, Professor Bob Young signing off. Have a great day.